We'll see if it goes better than it did this morning because my smartboard wasn't working right, so it didn't go very well. All right, this is worksheet 1 and 2. We'll see how far we get. I don't know. On notes on probability. We need to talk about the difference between theoretical and experimental probabilities. This is the definition of theoretical, and this is the definition of experimental. And one is not really better than the other. It depends on the situation. If you're talking about rolling a die, it's probably better to think of the experimental probability, which means the number of favorable outcomes out of total possible. So every time you roll, you have a 1 in 6 chance of getting each number. Does this sound familiar? Okay. If you're talking about shooting baskets, and you know that the person who's shooting is an 85% free throw shooter, then the probability of them making the next basket or free throw that they shoot is probably not 50%, which would be yes or no they make it, which would be the theoretical probability, but it's probably closer to 85%, which is the experimental probability, because you know you've done some experiments or found some data. So for example, if we had this spinner that had an X, Y, and a Z, what's the probability of getting a Z on this spinner if I made those all nice and equal? 1 out of 3. But if we did an experiment with that spinner and we found this was true, what did we experience the probability, the experimental probability for getting a Z? Yes, 13 out of 20, I think. Okay? Do you understand the difference, guys? Okay. If it's going to be experimental, they have to basically give you the information you need about some kind of experiment. Yes, that was a flash ad for my calculator missing. All right. Can I skip this one, guys? Probability of choosing a girl or boy in this class. We count them up. We figure it out. I just want to get to questions on the homework. So, there are some cards questions, and I know there are students who are not super familiar with a deck of cards. The things you need to know, that there are 4 of each suit. 4 suits, 13 of each. This is clubs, spades, hearts, and diamonds, top to bottom, but it doesn't matter if you don't know the difference between a club or a spade, okay? You just have to know that there's 4 threes, and there's 52 cards in a deck, and it goes ace, and then 2 through 10, jack, queen, king. Everybody okay? Let's practice on these questions real quick. Probability of getting a red?
No, 1/2.
Yeah, 26 out of 52 or 1/2. Hearts? Yep, 1/4. 13 out of 52. A red 7. 2 out of 52, which is 1/26. A black heart. Okay, all the hearts are red, unless you're Miss Hoffbauer, and then I have a black heart, right? I don't think so. Not after spending $60 on candy this weekend. Okay. A sample space, guys. If it asks you on a worksheet to list a sample space, that is not a probability. A sample space, you list the possible outcomes. So if you roll a die, the sample space is 1, 2, 3, 4, 5, and 6, because those are the possible outcomes. So real quick, probability of getting a 4, an even number, 3 out of 6. Number greater than 1? And a 7.
0.
Okay.
The common sense check right
All right. We were assuming traditional dice. Yes, you're very correct. Okay, just go with me here, guys. I realize that I did not choose good letters for their names. We have combination of Bill and John, Bill and Sue, Bill and Ann. Okay? We have John and Sue, John and Ann, or Sue and Ann. Do we need to list them in the other order?
No.
If you read the question, which I should have done first, their boss is going to pick a team of 2 people. So does it matter who's picked first? No. Sue and Ann and Sue are the same pair of people, so we don't need to list them again. So what is the probability that Bill and Sue get the promotion? That the team is made up of 2 men, which would be Bill and John. That Ann is one of the people. Yeah, Ann is on 3 of those possible teams, so that would reduce to 1/2. Everybody okay?
What an unfortunate series of letters.
Yep. It's nice. I could have. I figured you needed a little amusement today. Okay. A couple is planning on having 4 children. Write out the possible outcomes. Remember, birth order would constitute a different outcome. You could do a tree chart for a tree diagram, but I'm not sure if it's going to be any better to go this way. They could have a boy or a girl. If they had a boy first, then they could have a boy or a girl. This is never going to fit. Unfortunately, that's half the chart, and I'm not going to have much luck fitting over here, okay? Yeah, there are 16 possibilities. How many of them are going to be all girls? If you were to write out, like, this one right here, write out what gets you to this point, it would be boy, girl, girl. If you read down the path, okay? All girls, there's only going to be 1 out of 16. All boys? Okay. Do we need to do a whole bunch of fancy work to figure out at least 1 boy? If there's 16 different ways this can happen, how many is 1 boy, or all boys? So that means all the rest of them have it. Yeah, I don't think I said that right. Okay. The total possibility is 16. If the chance that they have at least 1 boy could be 1 boy, 2 boys, 3 boys, or 4 boys, right? So the only one that doesn't count is all girls.
Okay.
And that was 1/16. So it's 15/16, which is called the complement of having all girls. All right. So some basic stuff. The probability of an event is written like this often. The probability of any event is a number between 0 and 1. There's a worksheet where it asks what is the range of values for probability. 0 to 1. Inclusive. It can be 0 and it can be 1. The sum of the probabilities in a sample space is 1. In other words, if you add up the probability of each individual event occurring, it should total 100%, right? The probability of an event not occurring is 1 minus the probability of the event occurring, which is known as the complement. For example, if an event, the probability of an event occurring is 3/5, what's the probability that it doesn't occur? All right, we good? All right. Compound events can be independent or dependent. Independent is when you have two events that don't affect each other. For example, you're going to roll a dice and flip a coin. Okay? What's the probability you roll a 5? Is 1/6. The probability you flip a coin and get a tail is 1/2. So the probability that you were to get a 5 and a tail would be 1/12, because they don't, one doesn't affect the other. Okay? Roll a pair of dice. What's the probability that you roll a pair of 3s? 1/6 and 1/6 is 1/36. Now, that question changes a lot if it says what is the probability that you roll a sum of 3, because you could get a 1 and then roll a 2, or you could get a 2 and then roll a 1. So there's 2 out of 36 possibilities there. All right. If you have a question, you're going to take test A and you're going to take test B, guys. The chance that you pass A is 40%, so what's the chance you fail? Okay, the chance you pass test B is 20%, so the chance you fail is 80. What is the probability that you fail A and then fail B, assuming they are independent? Okay? Fail A was 60 and fail B was 80, so you get 0.48 or 48%. Pass A, fail B. Pass A, fail B. 32% of the time. Okay, fail A, which was 60. Pass B, which was 20. It's only 12. Okay, pass them both. Only 8% chance that you pass them both. Okay. If we add up all of these, 0.48, 0.32, 0.12, and 0.08, it adds up to 1. Okay? Because that's all the possibilities. You pass one, fail one. You fail them both, pass them both. All the possibilities are there. Right, dependent events are different. Dependent events are things like without replacement, okay? When one depends on the other. If you have a deck of cards, what's the probability that you pull 2 aces in a row without replacement? So the first time there's 4 out of 52 aces. When you go back to pull another one, there's only 51 cards left and 3 of them are aces. Okay? That reduces to 1/13 and 1/17. I think it's 221 maybe. Is anybody doing 13 times 17 for me? Okay. All right, if you have 30 students in your class, 17 are boys and 13 are girls, and we need to select a president and a vice president, what is the probability that we have a female president and a female vice president? So the first time we pick, what's the chance that we pick a girl? 13 out of 30. Now we've already picked and elected our president, what's the chance we pick another girl? Okay, I'm not going to bother to finish and reduce, but you get the idea? All right. Then there's what are called mutually exclusive events. But there's also, this is the problem when there's an overlap, okay? So these are not mutually exclusive. It says it can be so that they are, but I don't really use this concept. I'll show you, but then we'll talk about how I think about this. From a deck of cards, what is the probability of pulling a red card or a 2? All right, there are 26 out of 52 that are red. There are 4 out of 52 that are 2s, but there's an overlap of 2 out of 52 that are red 2s, which is this and business, okay? So you would get 28 out of 52 or whatever that reduced to. I don't ever do that. I just think about how many red cards are there and how many more 2s do I have to worry about that weren't red. I don't ever write this all out and, okay, I just think there's 26 red cards and there's 2 black 2s I got to add into that, so therefore there's 28 out of 52 cards that are going to work. Number of winners, number of total possible. That's all I do. All right, when you roll a dice, what's the probability of rolling a 6 or a 3? Yeah, 2 winners out of 6 or 1/3. What's the probability of rolling a 6 or an even number? Are these mutually exclusive? Or is there overlap? There's overlap, but how many winners total? Yeah, this says you win if you get a 6. This is if you get a 2, 4, or 6. Well, that just means there's 3 winners, so 1/2. All right. This one says, in a math class, there are 14 seniors and 8 juniors. 5 of the seniors are male, 4 of the juniors are female. I always just do a little chart. Okay. We have juniors, seniors, male, female. So 5 senior males. What else do we know then? It says there's 4 juniors that are females. Okay. How do we do those other 2 boxes? Yeah, 14 seniors total, so this has to be 9 and 5, right? And 8 juniors total, so 4 and 4. So what's the chance we get a senior or a male? What are the numbers that count? Seniors are 5 and 9, and all males we got to count, so we also got to count these 4 juniors, right? You see what I'm saying? We're talking about all of these people work as winners if we want a senior or a male. So that's 18 out of 22. Did I do that right, guys? I'm not going to. You would be expected to reduce. I'm not going to bother. Junior or female? All the juniors and all the senior females. So we get what? 17 out of 22, which doesn't reduce. What's the chance you pick a junior or a senior? 1. Any questions on that concept? All right. This says your doctor's going over the statistics of a risky operation. The surgery has a 25% failure rate. If the surgery works, there's still a 17% chance of infection. The surgery can fail and you will still get an infection 3% of the time. What are your chances of a successful infection-free surgery? The easiest way I think of to explain this, we can succeed or fail with the surgery, okay? It has a 25% failure, which means success is what percent? Okay. If we succeed, we can get an infection or no infection. If the surgery works, there's a 17% chance of infection. The chance that we get no infection would then be what? 1 minus 0.17 or 0.83. The surgery can fail and you still get an infection, but only 3% of the time. So most of the time if the surgery fails, you get no infection. How often? Okay. So what are the chances of a successful infection-free surgery? Success is 0.75. No infection is 0.83. So what are those when you multiply them together? So about 62% of the time, you will have successful surgery without an infection. Who knows what the surgery is for? I mean, all right, guys, let's keep going so we can get to homework questions. At a clothing store, statistics show that you can buy pants without trying them on. You have a 30% chance of being too tight and a 10% of being too loose. What's the probability they fit? Yep. Now, they're going with the assumption that those are your only two choices. They're too tight, or three choices: too tight, too loose, or they fit. Could be too short, too long, lots of other things in my opinion. All right. We're going to quit in just a second here. This one says, to meet state standards, Harlem does research and discovers that 80% of students need help with math. Okay? 70% need help with English, and 55% need help with both. Now, guys, when they quote this 80%, is that need help with math only? Well, can you have 55% that need both and 80% math only? Both math and English is 55%. Okay, 80% need help with math, so that includes the 55% that need both. So 80 minus 55 is, okay? The 70% that need help with English includes the 55 that need both. Now, what is the probability that someone needs help with math or English? And when they say or, they mean or both. Okay? What's the chance that you need help with math or English or both is what they're really asking here. Okay? All right, let's go through these quickly, and then I think I'm going to quit. Guys, this is what we were doing a minute ago. As far as I'm concerned, it's just reading the chart. What is the probability of picking out of these 140 people an independent? Total independence was 17 right here. Okay, production worker. 92 out of 140, which you would need to reduce. Independent or production worker, what are we going to do there? You could take all the independent, all the production workers, and then subtract off the independent production workers. I don't usually do that. I just go, okay, production worker, production worker, production worker, or independent. Well, that means we've got to include those, and I just figure out how many total winners. I don't do the plus and minus and all that whatever. It's really 92 production workers and 9 more, so it's 101, I believe. Okay? This is something different. Okay, this is a conditional probability. It says, what's the chance we get an executive given that we are choosing a Republican? This means only out of these 55, what's the chance that we picked an executive was 34. Everybody okay with that? Okay. And this one is given that we have chosen a production worker, so I already know I'm out of 92 people. What's the chance that we picked an independent was 8, which needs to reduce as well. All right. More on this tomorrow. No, Wednesday after the quiz.